This is most of the OWL energy monitoring system, comprising of a receiver, a transmitter, and what I don't have here is the little current clamp sensor. I do have a picture of it, but it's in quite a tight spot and a bit fiddly to try and get out, so we're not showing that particularly. It works well. Each unit takes 3 batteries, 3 AA batteries, and it lasts for about 2 months on good rechargeable batteries. And the transmitter, the batteries have gone flat, hence we're not reading anything on the display. What I want to do in this video is I want to modify this so that I can power it off a USB power bank. Basically, the way these systems work is that they have a little device called a current clamp. Here's a picture of it in situ. This is around one of your power leads coming from your electricity meter, just one of the leads, the live or the neutral. This one, I've got it on the live. This then plugs into this little receiver. And this particular model, you can have up to 3 connected, but I've only just got the one. But this reads how much current is being drawn, and it takes an average of that reading and sends it every, I think, 5 seconds, something like that. It transmits it to the receiver, which then displays it and can tell you how much electricity you're using over the course of a day, a week, a month, even a year, and just helps you keep track of things. But that's not what we're interested in today. What we're wanting to do is to take this slightly apart so that I can put a cable in which will connect to our USB power bank. As you can see, there are no, apart from these ports, there's no other ports on it, although it looks like on the casing there's space for one. But we shall see just how much effort it's going to be required to retrofit this with a USB lead, so it can plug into a USB power bank or even a USB plug, mains plug. So I'll approach in a bit closer here so that we can explore the insides of this together. As you can see, it's rated for 4.5 volts, so I plan on using just a single diode in line with the lead from the USB power supply, and this will drop it enough so that it'll keep it happy. One of the annoying things that several manufacturers do is that they put screws on the battery cover when there's not really a need for it. This normally sits in a cupboard and isn't really. Ooh, we got crustiness. Batteries leaked. Good job we've taken this apart. Let's just clean that out. Chuck these in the bin. One moment please. Hopefully we've caught that before it's done any damage. So even though they've used screws to go in for the battery compartment lid, it's actually nice that they've put them into threaded inserts. So at least that's something. There's no screws on this, so I think it's just a case of trying to open it. may be glued together. If this doesn't open, I'll just have to pause and maybe get a bit medieval on it. I'll be back in just a minute. Well, as you can see from the chewed up marks, this is a sealed unit. It's been probably ultrasonically welded, and I do want to keep this intact, so I'm kind of a little bit defeated on being able to take it apart and bring this cable in, perhaps through here. So what I'm going to do instead, I will either drill a hole in the side, probably drill a hole in the side, in through here, and then we'll just attach to both the positive and negative within here. I think it's the simplest way, and it still will be able to be put back to normal AA battery use, reversible if that was needed in the future. So I'll just get a couple of tools and I'll be back to do that modification. So first of all, I just want to mark up so I can get this hole drilled in from the outside in somewhat the right place. So as you can see, we want it in line with this. So we'll probably drill through right from the center there. There we go. Managed to get it in the right place. Now we can just nip the unneeded end off our USB and feed it through. Before we do that, let's just clean up our pencil marks. It's easier to do it when there's no cable in the road. So we just want to make sure that this has a bit of strain relief on it to stop it getting pulled back. Just mark up where it needs to be, and then sometimes some people tie a knot. I've done that a number of times. If you've got a cable tie, you can often just use a cable tie pulled nice and tight. That'll stop that getting pulled out. So now, do we trust that in this particular factory they've used black for the ground and red for positive? I think we would be as wise to just double check. So I've got a power bank here, which is one of these cheap Poundland ones that always stay on. We've got our test leads. And just to make it easier, I've put a crocodile clip on one of them, and then positive, and in this case they have done it as they should. 5 volts on the red. That's excellent. So I've brought you in a bit closer here just to show how these battery compartments often are wired up. You see that we've got 2 terminals here, this one for the negative, that's for a positive connection of the battery. They're just linked through together. Similarly on this side we've got the same arrangement here. We have the negative just linked straight through to this positive terminal for the batteries. This is so that the 3 batteries are in series. So this is the overall negative that obviously goes into the circuit board, and that battery is positive linked through to this middle battery is negative, and then this middle battery is positive linked through to this end battery's negative, and then this one is the overall positive. Now I'm going to attempt to solder to these 2 connections. It may or may not go well. There's been some battery leakage. I don't know how well these terminals will take some solder. We'll give it a try, but if not, it may be a case of physically wedging a connection into these so that they're made by a physical connection rather than a soldered connection. But I'll get the soldering iron on and we'll see what we can do. So I'll just set up a little clamp here to hold this over onto one side so you can see it a bit better. Flood too much flux onto there. Let's just see if we can melt some plastic. Seemed to take some solder. Melted a bit of the plastic as well, which really smells bad. And we can try and do the same on the other connection. Not forgetting, of course, we need our little diode just to drop the voltage a little bit. So just want to bend the tip of this over. This is just a simple 1N4001 or 4002. Just a simple rectifier diode I happen to have. And it's stuck. We can just tin the side of that. Get our negative attached. But before we attach the positive, what I'd like to do is I'd just like to find out what sort of current this is going to draw. So here we are. We've got it hooked up, the positive hooked up to this green test lead, and then the positive from the USB power bank comes in onto this yellow lead. Goes through the meter. It's in the milliamp range, and indeed the 4 milliamp range. This takes very, very little current. This is just it's mainly idle. As you can see, it keeps pulsing. And every now and again you get a really big pulse. Now the really big pulse isn't long enough to show up on the main display. It does show up on the bar graph, which is updated much more regularly. And it goes over range, so it pulses at more than 4 milliamps. But normally its background is, say, 2/200ths of a milliamp. So very low. In fact, so low that on our power bank here, it doesn't actually recognize that there's a load in it. It doesn't illuminate its little power LED, which normally comes on whenever you plug a load into it, and that doesn't illuminate. I turn this, we'll see if we can catch any of these bigger pulses. There we go, came up to about here. This is the 40 milliamp range, so maybe it pulses to about 10 milliamps, but that's not very often. So these are very low current devices. So I anticipate, in fact, no, I won't say, I will do some calculations as to what I think, how long it will last off one of these power banks. I've done quite a bit of testing on this particular power bank, so I know its capacities, and I will do those calculations and I'll put it up on the screen here now. So I just timed in between the larger pulses of current. It's about every 55 seconds, so maybe once a minute. It does have a mode where you can put it into a high update mode, but it only stays in that for a short period of time. In the high update mode, it will update, I think, every 2 seconds. So now we just got to solder this together. Take the power off. And put the leads back into the normal position so we don't blow any fuses. So that seems to be all that needs to be done with that. We can put the lid back on it. If this was a lid that was easily removable, I would probably put a bit of heat shrink over that diode and the connection to it, but as this is a screwed down cover, I don't see the need. To put it in the high update mode, you press and hold the button. And you may be able to see the light pulsing. I suspect that's where most of the current is being used. And that's how often it updates. But normally, whenever it's working, it's much less frequent that it transmits the data through to the receiver. So I hope this little project has been informative. Just a little modification that can be done. Make sure that we don't have any more leaking batteries in our transmitter. batteries seem to leak whenever there's very little current being drawn from them, so this hopefully will eliminate that. Plus it's easier to charge one USB power bank than 3 either disposable batteries or charging up 3 rechargeable batteries. I may in the future do a similar thing for this. This actually does have a DC input jack, but it says 6 volts at 50 milliamps, which is interesting because it only runs off 3 batteries. So I'm not sure exactly how that works. A little bit of investigation may be needed into that. But I'm not so worried about this one, because this is a nice little unit that can just sit beside me on the desk. Whereas this, well, it's not quite as neat a solution anymore, but it doesn't matter because this gets buried in a cupboard with the electricity meter, so that doesn't matter. So thank you for watching, and we hope to see you on the next video.